Hi, Algebra 2. In lesson 7, you're going to be looking at transformations of logarithms and exponential functions, and it's going to be really similar to transformations that we've done with a bunch of other functions throughout the year. Here we go. First, we're going to be looking at transformations of exponential functions, and I'm not going to talk through all of these individually because these are all things that you've seen multiple times throughout the year already, so this notation in the middle is the exact same. The thing that you're going to want to pay attention to are these examples, and you want to use those as we go forward. In example 1 here, we're going to be looking at two functions, g of x, which is the transformed function of the parent function right here, 2 to the x power. You have a table here to fill in and a graph to sketch these on. And I would also recommend using Desmos to help you see what's happening. So here I graphed g of x, which is 2 to the negative x plus 1. You can create a table out of that to get those values to fill in your table in your notes. And you'll see the function over here with that curve that we see. Now, the problem in your notes does say to describe the asymptote. And what we're talking about is the point or the line that your graph gets closer and closer to but never touches. So in this case, the asymptote is right here. It is the line of y equals 1, that horizontal line right there. Then you're comparing this to your original function, and we're talking about what happened here. So your transformation is that it moved up 1, and you can see that here that the asymptote is 1 unit higher. And then this negative x reflected it across the y-axis from the original. You can also use a table with your original function to get the values to fill in your table in your notes. And again, I would highly recommend sketching this on the graph in your notes so you have something to refer back to. In our next example here, this is a typo. This should say g of x for our new function, and we're going to compare that to f of x, our original function. Again, let's use Desmos, but make sure that you fill in your table and your graph in your notes. All right, so I've graphed g of x is our red function here, and I'm going to turn that into a table. That's what I would use to fill in that table in your notes. And same thing with f of x, our original function right there. And now we're comparing them. I can see in my red function that it is moved to the right 2 units, and I can use that or I can compare that with the points that I have here. So this point was moved to the right 2 units. This one would also be moved to the right 2 units. This one would be moved to the right 2 units, so on and so forth. And that's because x minus 2 right here, that is affecting your x values. That's your horizontal value, so it's moving it to the right 2 units. The asymptote is still the same. The asymptote is going to be y equals 0 on this one. In the next example, we have g of x right here. F of x is going to be just 1.5 to the x power. So in both of these, the asymptote is still going to be that y equals 0 line. And I can see that my red line is g of x here, and it's been compressed, that vertical compression. And that's because the whole function is being multiplied by 2/3, so that's affecting your y values. When I zoom in and I look at the y-intercepts, here we can see that compression of 2/3. So in the original function, the y-intercept was at 1, and in the new function, the y-intercept is at 2/3. This is the decimal approximation. So we've taken those y values and we've multiplied them by 2/3, which makes them shorter or compressed to the x-axis. In our next example, here's going to be our function h of x, and we're going to compare it to f of x, the parent function, which is just going to be e to the x power. Okay, on this one, I'm going to start with our parent function, or the original function. F of x is e to the x power. You see that right here. We are eventually going to get to h of x, but this has two transformations going on. I have a +1 and I have a negative x happening. I'm first going to think about what's happening to the +1. It's affecting the x value, so I know it's going to be going left or right. From what we've talked about before, we know that that is going to be moving our function to the left 1. And if I turn that on, you can see that the green function is moved to the left 1 unit. Then, so we move it to the left 1. Now we're going to worry about that negative x part, which is going to reflect it across the y-axis. And so then you turn on the red one here and you see that, yep, the red is reflected across the y-axis from the green one. And so we have two reflections happening First, it moved to the left 1 unit. We can see that with our green one. And then we reflect it across the y-axis. When we start looking at transforming logarithmic functions, same notation that we've been working with is going to be in place. You're just going to be looking at these examples for how that's going to look with logarithmic functions. First function we're looking at here is going to be 5 times the log of x minus 2. So I have something being multiplied by the entire function. That's going to be a vertical stretch. And then we have this minus 2 on the end of the whole function. Notice it's not in parentheses with our x. It's being subtracted from the whole thing. So that's going to be a vertical translation, a move down 2 units. When we look at our graphs here, we can see in this case we have a vertical asymptote of x equals 0. It's not going to touch the y-axis. The blue line is our original function of just log of x. The red line is our transformed function. So you'll see that we do have that vertical stretch happening, and we did move it down, 2 units. It's kind of hard to see just the way that these graphs turn out, but that is what's happening here. So use that table on the previous page to really help sort through those transformations. In our next example, we're working with a natural log. We have the natural log of negative x plus 2. To work up to this h of x function that we're looking at in this example, I'm starting with our parent function, just the natural log of x. So you see that here in green. Next, I'm going to turn on the transformation of just the plus 2. Now we know that if we are adding 2 to the x, that's going to move it to the left 2. That's the same as other transformations we've done this year. Then, you can see that in blue there. Then lastly, we have a negative x, which is going to be that reflection across the y-axis. So we turn on the red one, and you can see that happening there. So sometimes when you're trying to work with these transformations, kind of build them in your graphing calculator. Start with that parent function, and then build each transformation so you can see what's going on in each step. All right, guys, nice job challenging yourself with this should-do lesson. These transformations are really kind of getting repetitive, same stuff over and over again, but it's good to see what they look like with different functions. So nice job. Keep at it, guys.